Good day, class. This is a review lesson on half-angle identities. So write down the title, Review on Half-Angle Identities. Okay? You've been exposed to this previously, but this lesson goes over an additional problem for you to gain extra practice. Alright, so let's write down the learning objective first, and then we'll look at an example. So learning objective. Alright, write this down. By completing 70% of the graded classwork problems, you will apply the half angle identities in evaluating trig functions. Okay, so that's the learning objective for today. Now let's take a look at an example. Example number one. Example one. So let's try this problem. Find the exact value. Find the exact value of sine 7 pi over 8. Alright, so first thing I want to do is look at this angle right here, sine 7 pi over 8, and I can ask myself, is this angle a common angle, or is it on the unit circle? So let's look at our unit circle real quick. 7 pi over 8. Let's see, 7 pi over 6. I do not see 7 pi over 8, 7 pi over 4. 7 pi over 8 doesn't seem to be on the unit circle, so I have to work on that. So I don't even like dealing with radians to begin with. How about we convert this angle into degrees to make it easier to work with? So what is 7 pi over 8 in degree measure? We need to multiply by the conversion factor. Since pi is on top, we need pi on the bottom, and pi is equivalent to 180. Alright, so you multiply this, the pi's cancel out. 4 goes into 8 two times, and 4 goes into 180 45 times. When we multiply across, you will end up with 315 over 2, which is equal to 157.5 degrees. This is clearly not on the unit circle because they're all whole angles, okay? So that's not on the unit circle. So we know that alpha over 2, since we're working with half angles in this problem, alpha over 2 is going to be 157.5. Now if I double this, do I get something in unit circle? Hopefully. So if I multiply this by 2 and multiply this by 2, I'm going to end up with alpha equals 315 degrees. Now is this on the unit circle? 315. Let's take a look at it. 315 is right here. Root 2 over 2 and negative root 2 over 2. While we're at it, why don't we just write down the coordinates of that point? So 315 is root 2 over 2 and negative root 2 over 2. Remember, from a unit circle ratios that the x coordinate is cosine and your y coordinate is sine. Okay? So what does this problem call for? This problem calls for sine alpha over 2. So because we have a sine situation here, so sine alpha over 2 equals what? We use a different color. Sine alpha over 2 equals what? Sine alpha over 2. If you do not have your formulas already memorized, which you should have by now, you can take a look at the half angle identities for sine, and it is plus or minus the square root of 1 minus cosine alpha over 2. Okay? So let's apply this formula to this problem. So in this problem we have sine 7 pi over 8. Let me partition my workspace. Sine 7 pi over 8 is the same thing as sine 157.5. Alright? And then when I plug it into the formula, it is equal to this plus or minus the square root of 1 minus cosine 315 divided by 2. Remember, it's double the angle that goes here. It's alpha that goes here. Remember, alpha is 315. Alpha over 2 is what is the argument for the trig function, but it is double the angle that goes into the formula. Alright, so keep that in mind. Now, what is cosine 315? We have the coordinates here. Cosine is root 2 over 2. So cosine 315 is going to be root 2 over 2. So that gives us, this is going to become plus or minus the square root of 1 minus root 2 over 2 over 2. Okay? Now let's write this as a fraction. This is a fraction, so we might as well write this as a fraction. So this is where people are getting lost the other time. So please pay close attention to what is going on here. I need to have the same lowest common denominator. So these two have to have the same LCD. The LCD of 1 and 2 is 2. So I can multiply this by 2 on the bottom and on the top. Okay? Multiply it by 2 on the bottom and on the top. So that gives me plus or minus the square root of 2 over 2 minus root 2 over 2 over 2. Okay? So what does that become? It becomes, you can now write it as plus or minus the square root of 2 minus root 2 over 2, and then the whole business over 2. So if you have a fraction on the bottom, on the numerator, we might as well make the denominator fraction. We have a fraction divided by a fraction. So in this case, you multiply by the reciprocal of the denominator, or you DCF the problem. So you have plus or minus the square root of 2 minus root 2 over 2. You drop the top, change it to a times, and flip the bottom into 1 over 2. So that gives us plus or minus the square root of 2 minus root 2 over 4. Now you may not cancel in this direction because you're canceling a difference. You cannot divide minus because minus is not the opposite of division. If this were times, then you may do that. But since this is a minus, division cannot break a subtraction. Only the addition of its opposite can break this. Okay, so don't cancel in this direction. That's an illegal move in the mathematical world. Alright? But you may not have a fraction as a radicand. So we need to break it up. Plus or minus, we do the numerator and the denominator separately. So if I do the top remains 2 minus root 2. What do you get when you root the bottom? If you root 4, what do you get? You simply get 2. Alright? So is it plus or is it minus? Is it plus or minus? Well, let's look at the problem. The problem asks us for sine 157.5. So where on earth is that? What quadrant is 157.5? Let's see. If I do my coordinate system like this, I know that this is 0, 90, 180. 157.5 is somewhere here in the second quadrant. I know animal students take calculus. S, second quadrant, sine, sine. That means our answer is going to be positive. So sine, I don't have to write this. I can write 7 pi over 8 because it's exactly the same thing as that. But in radian form, this is what you have equals the square root of 2 minus root 2 over 2. Okay? So note there are two angles here. Don't confuse it. This is a half double angle. This is half of the angle. Whenever you're using animal students take calculus, look at the original angle, the original problem, which is 157.5 or 7 pi over 8. Alright, so there goes your answer. Thank you for watching this video. Hope it helps. You can go over it again online if you need additional review.